Okay, we started working on radicals today. We're going to continue in our problems with radicals. Now we know what a radical is. We know how to convert it from radical notation to fractional exponent and back again. So today we're going to operate with radicals. You have a question, Tony?
Yeah, on the homework. Number 55 and 56.
55.
A couple of them had the negative sign on the outside.
And that means you want a negative for the answer. That's all it means.
Okay, if you get like negative x squared y cubed,
that's it.
You don't have to bracket it.
No.
Wasn't the y negative?
No, the whole thing's negative. The whole factor is negative. In other words, if you have something like this, negative square root of x to the fourth y to the sixth. You see, whatever sign is in front of the radical, that's what we're talking about. If there's no sign, it's understood to be a positive. If it's negative, it's understood to be negative. We want the negative answer. So we take the square root of x to the fourth, well, that's x squared. Of y to the sixth, that's y to the third. And there's your answer. Okay? The whole thing. Okay. Now, before we go on, we need a new property. Our property is this. This is property number 9. 10.
I think so. 9.
Okay. Property 9, we're going to be talking about operating with radicals. So we're going to first of all talk about multiplication of radicals. The nth root of A times the nth root of B is equal to the nth root of AB. Now we can prove that very, very easily. The nth root of A, if we take this out of radical notation, this is A to the 1 over n times B to the 1 over n. Since they're both raised to the 1 over n power, we can say AB, all raised to the 1 over n power, which is equal to the nth root of AB. Very simple proof. Now, all we're saying here is that in order to multiply radicals, they must have the same index. And then all you do is you multiply the radicands. And this is a two-way street. This is equal to this. Likewise, that is equal to that. Remember that. Important. Okay. If I have the square root of 2 times the square root of 3, this is going to equal, by our property, square root of 6. Okay? If I have the 7th root of x cubed times the 7th root of x squared, this would equal, help.
7th root of x to the 5th.
7th root of x to the 5th. And again, if you want to prove it, it's very, very trivial. Just take it out of radical notation. This becomes x to the 3/7 times x to the 2/7. Anytime you multiply like bases, you keep the base, you add the exponents, it's x to the 5/7, which is equal to the 7th root of x to the 5th. So it's easy to verify, but we don't have to verify. We know it's true. We proved it's true up here. Okay? Any questions on multiplication of radicals? Okay. Square root of 4. Wong.
It's 16.
What's the square root of 4?
16.
One more time. Square root of 4. What number?
2.
2. Okay. Square root of 9, Wong?
3.
3. What we're saying here is we're saying what whole number times itself will give you 2? I mean 4. It will be 2. What whole number times itself will give you 9? Well, that will be 3. What whole number times itself will give you 8? None. There is no whole number times itself. So square root of 8, that's not a perfect square. but we can do something with it. We can simplify it. Help. Yes.
Square root of 2 times 4.
Square root of 2? He says, well, it's 8 is square root of 4 times 2. By property 9 up there, this is equal to the square root of 4 times the square root of 2, which is equal to 2 square roots of 2. Okay? Now, you see what you have to do then. These are equivalent statements. This is in simplified form, 2 square roots of 2. So by Tony's method, we have to look for perfect roots, perfect squares, perfect cubes. We have another method, an alternative method, that I think you'll find a little easier in the long run. Maybe not for this particular problem, but overall, let's take square root of 8 again. What we're going to do is we're going to break down the radicand into its prime factors. Prime factors. By prime factors, we mean factors that can't be broken down anymore. What would be the prime factors of 8? Help.
8 and 1.
No, prime. Prime. Numbers that can't be broken down anymore. 2 times 2 times 2. They are the prime factors of 8. We now take a look at our index. What is the index for this particular problem? 2. What that is telling us is that for every 2 factors that are identical in the radicand, we can cross them out and bring one outside. For every 2 that are the same underneath the radical, we can cross them out and bring one out. So we have 2 square roots of 2. Notice it has to be the same as Tony's. It is. But you're going to find this, as I said, in the long run, much easier, much faster, much better. Break it down into prime factors. Look at the index. The index tells you how many factors you need the same in order to bring one out. Okay? Let's try about 6 or 7 of these. Let's suppose we have the square root of 50a to the 3rd. And what I'd like you to do is simplify that radical. Okay, we get an answer for this. Kathy.
5a times the square root of 2a.
Very good. Very good. We break this down into prime factors, and most students have trouble with the arithmetic. Let's break it down to numbers you know. 50. Well, that's 5 times 10. But 10's not prime. 10 is 2 times 5. A to the 3rd, well, that means A times A times A. Now that we have it in the prime factors, we look at the index. Our index is 2. That says for every pair of factors the same, we can cross them out and bring one outside. Well, I have a pair of 5s. Bring one out. I have a pair of 8s. I can bring one of those out. So what we're taking out is a 5a. What is left inside the... Well, it's 2a. Now this works all the time. If you didn't know the square root of 36, you didn't know what that was. You break it down into prime factors. Well, that's 2 times 18, which is 3 times 3. There are the prime factors. You now look at the index. That says for every 2 that are the same, every 2 factors identical, cross them out, bring one up. We have a 2 up, we have a 3 up. So outside we have a 2 and a 3, that's 6. Inside we have nothing left, we leave it alone. And there's your answer. It always works. Okay? Think. Let's suppose we have the cube root of, let's see, 24 x to the 4th, y to the 5th. Okay, let's take a look at this problem. I'd like you to show you the most frequent mistake students make. It will be the most frequent mistake on the next test. The most frequent. Even with this warning, it always turns out to be the most frequent mistake student makes. Let's take a look. We're going to break that down into prime factors. Again, arithmetic. Break it down into the numbers you know. 24. Well, that's 4 times 6. 4 is 2 times 2. 6 is 2 times 3. X's. Well, we have 4 X's. And we have 5 Y's. And there it is in prime factors. We now take a look at the index. Tim, what's the index? 3. That says for every 3 identical factors, you can cross them out, bring one outside. So we can take out a 2. We can bring out an X. We can bring out a Y. That's all we can take out. So outside we have 2xy. Inside we have 3xy squared. And there is the most frequent mistake students make on the test. What is the mistake? What's wrong, baby?
Like the square root? 2?
Yeah, it says cube root. If you start, you have cube. You better end up with a cube. See, if you have 2xy times the square root of that, You still can take out a y. So be careful. See how nice and easy this is? Right, Tony? Much better than looking for something. It will find you. Let's take a look at another problem. Oh, big number, big number. 162. X to the 4th, y to the 6th. Take the 4th root of it. That's the 4th root of 162, x to the 4th, y to the 6th. 4th root. Okay, let's take a look at this problem. The hardest part of this problem is the arithmetic. Now you have to use some of the mathematical insight that you have. You have 162. Well, what number do you know has to be a factor of 162?
2.
2. Sure, anytime you have an even number, you have a factor. So 2 is a factor. And we get 2 times 81. 81. That's what we have. Well, would 2 be a factor of 81? No, it's not even. Will 3 be a factor of 81? Sure it is. Do you know how to tell if 3 is a factor?
Add the 2 together.
Add the numbers up. If it's divisible by 3, 3 is a factor. See, if I add these up right off the go, I get 1, 6, and 2, that's 9. 3 divides evenly into 9, so 3 is a factor. But we have 81. 3 divides into 81, and we get 3 times 27. 27, well that's 3 times 3 times 3. Our x's. We have 4 x's and 6 y's. By tomorrow, you won't have to write all these. You'll come up with your own method of doing this. We now take a look at our index. Our index is 4. That says for every 4 identical factors, we can cross those 4 out and bring one of those outside. So we have a 3 out. We have an x out. We have a y out. So outside the radical, we have 3 and an x and a y. Inside the radical, the 4th root of 2y squared. Nice, simple. It always works. Let's try one more. Let's suppose we have 5 square roots of 12. 5 square roots of 12. Mike, you get an answer?
Not for right now.
No. Kathy?
10 to the square root of 3.
10 square roots of 3. That's it. Let's see how we get it. What we're going to do, first of all, is to break this up into prime factors to radicate. Well, that's 2 times 6, which is 2 times 3. We now take a look at our index. It's 2. It says for every 2 identical factors, we can cross those 2 out and bring one of them on side. So that's all we can do. Well, we brought a 2 out. We already had a 5 out there. The question is what to do with this 2 and 5. Well, it says to multiply. So 2 times 5 is 10 square roots of 3. Okay? Everybody got that? Now, important. Anytime a radical can be simplified, it must be simplified. Remember when we have fractions, anytime a fraction can be simplified, reduced, it must be. Same here. Anytime a radical can be simplified, it must be simplified. Now that we know how to simplify radicals, we can go into operation of radicals. And today we're going to talk about addition, subtraction of radicals. Let's suppose I have 8 times the square root of 3 plus 5 square roots of 3. Help. What do you think this is going to equal? What do you think that this is going to... Beeb, what do you think this is going to equal? Take some kind of guess.
13 to the square root of 3.
Right. She said 13 square roots of 3. That's correct. Now remember, when you first learned addition, you learned that in order to add anything, they have to have the same labels. And then all you do is add their coefficients. 8 apples, 3 apples. 8x, 3x. 8 square roots of 3, 5 square roots of 3. Okay? And we can show you that her answer is correct. Very, very simply. How many terms do we have in this problem? 2. Question. Is there any common factors that I can extract from these 2 terms? Do they have anything, B, what do they have in common that I can take out? Square root of 3. If I extract the square root of 3, that means I'm going to have to divide each of these by the square root of 3. I come out with 8 plus 5, as Beeb says, is 13 square root of 3. That's simple. Okay, let's take a look at this problem. 7 square roots of 5 minus 2 square roots of 2 minus 9 square roots of 2 minus square root of 5. See if we can find an answer for that expression. Okay, Wong, what you get for an answer?
7 radical 5 minus 11 radical 2.
I didn't get that. He said 7 square roots of 5 minus 11 square roots of 2. I didn't get that. Kathy?
I got 6 square roots of 5 minus 11 square roots.
6 square roots of 5 minus 11 square roots of 2.
Oh, this
Now,
one.
yes, you sure did. You missed the last one. Now, if I would have written this problem as 7x minus 2y minus 9y minus x, no one in the class would have missed it. But now instead of x's and y's, I have square roots. So everyone thinks it's an entirely different ballgame. But it's exactly the same. The only things we can add are those terms that have the same label. Then we add their coefficients. Our first label is square roots of 5. There are 2 of them. So we have a positive 7 and a negative 1. That gives you 6 square roots of 5. Next label is square roots of 2. We add their coefficients. Negative 2, negative 9 is a negative 11, and we're talking about square roots of 2. And there's your answer. You cannot combine these. They have different labels. Okay? Everybody see that? Okay. Let's try this one. 6 square roots of 20 minus 8 square roots of 45 plus 2 square roots of 125.